Welcome to a slow, beginner-friendly lesson on the none value, made for absolute beginners. None is special. This whole lesson is only about what none means and how it looks in code. So what exactly is none? None means the absence of a value. When a variable holds none, it is saying, I exist, but I have nothing inside. This is different from holding 0, because 0 is a real number. It is different from holding an empty string, because that is still a piece of text, just short. None is the deliberate nothing. It is the value you use when a real answer does not exist yet, or when there is genuinely nothing to report. The deliberate nothing. How do you write none? It is a single word, none, with a capital N and no quotes around it. Notice the similarities with true and false. All three are special words in Python, capitalized, written without quotes, meaning they are values themselves, not text. You do not write none in quotation marks, because that would make it a string containing the word none, which is a completely different thing. The capital N is not decoration, it is the rule. Capital N, no quotes. Imagine an empty container waiting to be filled. That is none. The container exists, it has a name, it has a place on the shelf, but right now it holds nothing. It is not holding 0 items counted, it is simply empty, awaiting a real value to arrive. An empty container. Every value in Python has a type, and none is no exception. The type of none is called none type. Just as the value 5 has the type int, and a piece of text has the type str, the value none has the type none type. And here is an elegant detail. None is the only value of none type. There are many ints and many strings, but there is exactly one none. You will meet the word none type mostly when inspecting values, so recognize it as the type of nothing. One type, one value. Let us confirm the type in code. We set a variable called nothing to none. When we print it, Python shows the word none. When we ask for its type, Python says class none type. So none is both a value and the sole member of its type. This is a good way to explore an unfamiliar value. Whenever something prints as none and you want to be sure, ask for its type, and none type will confirm that you are indeed looking at nothing rather than a string or a number. Ask for the type. Where will you actually meet none? In 4 common places. First, a variable you created but have not given a real value yet. Second, a function that does not explicitly return anything, which we will see in a moment. Third, an optional field in data that was left blank. And fourth, a search or lookup that found no match. In each case none is Python's honest answer, there is no value here. Recognizing these situations is most of the battle in understanding none. 4 common places. Here is the place beginners meet none most often. When a function has no return statement, or a return with nothing after it, Python hands back none automatically. The print function is the classic example. Print does its job, showing text, but it does not give you a useful value back, so it returns none. This is by design. A function either produces a value to hand back, or it returns none to say, I did my work, but there is no result for you to use. No return means none. A clean sweep, nothing left behind. Sometimes the most useful thing a function can hand back is the confirmation that it finished, with no value attached. None plays that role. It is the empty hand, the task done with nothing to show but the doing of it. Far from being useless, that kind of nothing is essential. The empty hand. Let us see a function returning none. We define say hello, which only prints and has no return statement. We call it and store the result. The greeting prints, but when we print the result, we get none, because say hello gave back nothing. This trips up many beginners, who expect the result to be the greeting. It is not. The greeting went to the output, and the function's return value is none. Always check whether a function returns a value before storing its result. Check before you store. Now a crucial distinction. None is not the same as 0. 0 is an integer, a real number, the count of nothing. None is not a number at all, it is the absence of a value. Imagine a temperature sensor. A reading of 0 means the temperature is 0 degrees, a real measurement. A reading of none means the sensor has no value to give, perhaps it is offline. Confusing the two would be a serious mistake. 0 is an answer, none is the lack of one. 0 is an answer. The same logic separates none from an empty string. An empty string, 2 quote marks with nothing between, is a real piece of text that happens to have 0 characters. None is not text at all. Think of the difference between an empty box and no box. The empty box exists and is ready to hold something, it just happens to be empty right now. No box means there is nothing even there to fill. In data, an empty string often means blank, while none means missing entirely. Empty box, no box, a spotless, empty room. That is the feeling of none among values. Not a room with 0 chairs, not a room with an empty shelf, but a room whose purpose is simply to be absent of content. Once you separate empty from absent, a lot of confusing data suddenly makes sense. Absent, not empty. One more distinction that catches beginners. None is not the same as false. False is a real Boolean value, a definite no. None is the absence of any value, not a no but a non-answer. There is a subtlety here. In a condition, Python treats none as falsy, meaning it behaves like false inside an if. But none and false are still different values, and they are not equal. Behaving like false in a condition is not the same as being false. Hold that nuance, it saves real bugs. Falsy, but not false. Let us gather the three distinctions together, because this is the heart of the lesson. None is not 0, 0 is a number and none is no number. None is not an empty string, a string is text and none is no text. None is not false, false is a Boolean answer and none is no answer at all. Four completely different things, each with its own type and its own meaning. Mixing them up is one of the most common sources of beginner bugs, so drill this distinction until it is automatic. Four distinct things. How do you check whether a value is none? In Python, the correct way is to write is none. For example, if result is none, you might expect to use a double equals, like result equals none, and it will often work, but the community strongly prefers is. The reason is subtle, is checks whether two things are the exact same object, not merely equal in value. Since there is only one none in all of Python, is the perfect and idiomatic test for it. Is none is idiomatic. A hidden trap waits for those who confuse nothing with empty, or absent with 0. The trap looks harmless until your program silently treats a missing value as a real one, and the logic bends in ways no one expects. Knowing none, truly knowing it, is how you step cleanly over the trap every time. Step over the trap. Here is the idiomatic check in code. We set result to none, then write, if result is none. Python sees that result really is none, so it prints no value yet. This is the clean, recommended way to test for none, and you will see it constantly in real Python code. Read it aloud, if result is none, and it almost sounds like plain English. That readability is no accident. The is none pattern is one of the most readable tests in the entire language. Readable as English. Let us clarify the difference between is and double equals, because it matters here. Double equals asks, do these two values have the same content? Is asks, are these two values the exact same object in memory? For none, you always use is, because there is only one none in the whole program, so identity is the natural test. For numbers and strings, you usually use double equals, because you care about the value, not the memory location. None is the special case where is shines. Identity over equality. Where does none show up in real code? In optional function arguments, where a parameter defaults to none meaning the caller did not provide it. In lookups, where searching for a key that does not exist returns none rather than crashing. In variable initialization, where you create a name now and fill in a real value later. And in sentinels, where none marks not yet set. None is everywhere once you start looking, and it is always signaling the same honest idea, no value here right now. None is everywhere. The most common none mistake looks like this. You call a function, store its result, and then try to use that result as if it were a real value, only to discover it was none. For example, calling a method on none gives an attribute error, because none has almost no methods. The fix is to check whether the result is none before using it. Once you internalize that functions without a return give none, this whole class of error stops surprising you, and your code becomes far more robust. Check the return value. Let us hold the whole lesson together. None is Python's value for the absence of a value, the deliberate nothing. Its type is none type, and none is the only value of that type. None is not 0, not an empty string, and not false, each of those is a real value of a different type. And the correct way to check for none is to write as none. If those four sentences feel true, you understand none, and you have completed the foundational types of Python. 4 true sentences. The takeaway, compressed. None means no value here. Functions that do not return anything give you none, so always check before you use a result. None is its own thing, distinct from 0, empty string, and false, and confusing them is a classic beginner bug. Test for none with is none, the idiomatic and correct way. That is the whole atom. You now know every foundational type in Python, int, float, str, bool, and none, and that is a genuine milestone. The core types are done. Where does this lead? You now hold every foundational type, integers, floats, strings, bools, and none. The next lessons ask what happens when these types meet each other, starting with mixing types carefully, and then the operators that combine values into expressions. Each lesson adds one brick. For now, take a breath and appreciate how far you have come. Knowing the types is knowing the raw material of all Python programming. Everything ahead builds on these few simple ideas. Onward to mixing types. Think of none as a parcel labeled nothing, delivered on purpose. The delivery matters, the label matters, the intent matters, even though the contents are absent. Programs exchange these parcels constantly to signal that a value is genuinely missing, and that signal is every bit as meaningful as a real answer. A parcel of nothing. Thanks for watching. Next, mixing types carefully.